Oh, maybe he's coming in. That would be nice. All right, so this is post from module 6. It's the input output lesson questions. Nick, I guess you're back. You're in, I mean, I should say.
Yeah, man, I was having trouble on my computer joining though. I'm sorry about that.
That's okay. That's okay. I totally understand it. So today, I would say before that, we're going to take care of some of the more theoretical concepts that will help us understand some of the material that is coming up, and especially the language. I would like you to turn this in by the end of the period, because I'll be answering the questions with you. And so if you go to post 6.6, which is in module 6, right here, then we can click on the website, and that should take you to, did I click or no? Maybe I didn't click. There we go. There. So if we scroll down to the PDF, we need the PDF. The PDF has the content for all this, the material that we're covering. So let me make sure that I have all the students in here. I think so. Let me check. Open this PDF right here. And we're going to go to talk about some interesting stuff. It's a little bit more advanced. And let me just get you in my attendance. And I think everybody's here. Oh, I was lying. Okay, then probably I do. No, I'm missing one person. All right. It looks like the cohorts have no change. And there's a birthday soon on the 14th. Arman, happy birthday.
Thank you.
You're welcome. I think actually we're going to be in class the 14th, right? Yeah. All right. So hold on a minute. Let me just make sure that everybody has. And I know I'm missing one person. I can do that in a few minutes. I'd rather move on with the lesson. I think did I see this already? Okay. Zoom crash. Yes. Ah. Oh, it's outside. James, is that noise coming from you? My computer? Oh, no, nothing. Okay, I don't know. Sometimes there's so many devices in the house that I don't know where things are coming from. All right, so I think I'm ready now. So let's just scroll down. I want you to work with me, okay? So you can turn in this assignment. When I finish talking, we have it all together. And I want you to ask questions if something is, too far out there that you have no idea what I'm talking about. And let me get your names over here so I can call you without having to show your face because I'm recording. So what they have over here, and you've probably seen it in other PDFs, is an interesting layer of components from about the language itself. As you can see, you have the basic stuff, primitive data types, assignment statements. We talk about the math library, which you can use random and a whole bunch of other things. We also learn to do input output just with text, conditionals and loops. As you can see, we didn't do arrays yet. We kind of did it, like informally, but I switched it around a little bit because I wanted you guys to get started with some of the graphics. And then these two are going to be interacting or exchanging places pretty often. And the same thing with functions and modules, except that the only difference that I have with what the university does is that I'd like to use functions in objects. I'm more into object-oriented because this class is kind of a feeder to the AP class. And College Board likes to think of objects first. And there is a lot of philosophy behind that pedagogy, a lot of philosophy that I'm not going to go into. So let's take a look at what we're going to be thinking in terms of that layer over here, input, output, and it shows up again over here, input, output. And that's a big, big topic. In Java is very hidden. It's kind of not that visible. When I first started teaching this class, the College Board was testing with C++. So in C++, you are closer to the hardware or architecture, a little closer, not that much, but a little bit closer. And you understood what a string was, like an input stream, an output stream, things like that. But right now it kind of gets, kind of dissolves a little bit because Java hides it. It makes an abstraction out of it. And that's what many times one of the ideas behind abstraction is you hide some of the very technical, very minor and things that maybe you don't need to know. We're going to go a little bit more in a few seconds. So here we have input devices, and here we have output devices. So these particular things, input and output, are also called abstractions because certainly you're not pushing something inside, right? Inside a computer. You're not pushing it in. You're not having in all the information. You do something that becomes input to the computer, and that's an abstraction. And when something, yes?
But I think just like the instructions, like the statements are the inputs.
That is correct. Yes, and that would be an abstraction of input. And then when you say print, System.out print line, that's an abstraction of output. Certainly it doesn't come out of the computer, right? It comes on the screen, and that's also an abstraction. It's a representation. It's a model. And of course, as an abstraction, we have a very minimized representation of what the physical thing might be. So if we are going to answer the first question, what is an abstraction? If I'm not mistaken, we can look at it over here. What is an abstraction? And I think the questions are here too, right? Yes, right. So I would like you to copy and paste the questions. I did not put that in there, did I?
No.
These questions before the end of the class. Yeah, copy the questions and answer them just below them because sometimes the numbers get all jumbled up. And then I had to figure out myself what's the answer to. So and then we can say that an abstraction is something that exists only as an idea. But I want to add more to it because it's going to be essential for later on when we do object-oriented. An abstraction is a very minimalistic view or idea, if you want to call it, about something real. So I'll give you an example. When you drive a car, some of you probably are already going through driving lessons and things like that. And so what do you care about the car? What are the things, and let's say you're not driving or you're not taking driving lessons, but you've seen people driving. So what do they care about? Tell me the things that the driver cares about. In terms of the car, okay?
How fast you go?
How fast you go. But when you look at the car, if you wanted to pull it out of the driveway, what do you have to do?
Put it in reverse.
Okay, there you go, it's in reverse. So you have to know more or less how to put it in the, in the right gears, whatever you want to call it. What else? What is the most important thing that you need to know that the car has? Otherwise, it's not going anywhere.
Wheels.
Okay, wheels, very good. What does the engine need?
Fuel?
What does the engine need to be able to actually
Gas?
gas? That's correct. So I don't know you, but usually I keep an eye on the gas, reader, sensor, or whatever you want to call it, dashboard, all the time to make sure that I know that I have gas. I also have to know how to turn the wheel, where the gas pedal is. What else?
The brakes, like where they are and how to use
That's
them.
right. You need to know where they are, the minimal things to be able to drive the car, which is the wheel, let's say, the gas, of course, the gas pedal, the brake pedal. All those are the most elementary things that you need to know. Do you really need to know how the engine works? No, right? So we make our knowledge is actually it is an abstraction of what the real thing is.
But how do you define that properly? Like, I think that's just like an interface or something.
Right. You need the public. We call it in programming. We call it the public interface. Zoom, and anybody who's having problems with Zoom, I'm recording this lesson. Okay, so don't worry about it. I'm sorry that you're having problems there. Yes, that's what we call the public interface, meaning you're the layman, you're not a technician, you're not a mechanic, you're the regular person who barely knows very little about a car. So all I guess that public interface, which is the average, right? So that's what Ian's referring to, which is the interface. So the interface will be the abstraction. We can say that. So good abstraction simplify our view of the world. Also, we try to minimize the amount of details about the real world, so we don't have to worry about that. We only worry about the important things that matter to us when we're doing development. So let's take a look at what is it talking about when it says, what is an input and output abstraction? So if we go over here, right, it says it's right somewhere here. And I think we already went through that, abstraction to provide input and output. So a terminal allows you to actually have input, right? Here's the input argument. And here's the output. So a terminal is a good abstraction of input and output of a program. That's an abstraction. And again, once again, we are only caring about what Ian called it the interface, because it's just what we can handle from that particular the terminal in this case, that device. In this case, the terminal. And then here has a whole bunch of things. He has a mental model if they wanted of what they use the black box. Anybody knows what a black box is? Let's not talk about the airplanes with the black box, the black box. Who knows what people call it?
Black box is something that takes input and it gives you output, but you don't necessarily know what it's doing inside.
That's right. A black box is something that is closed. You don't know what's going on in there. All you know is that you can put input, just like Nicholas says, and it will give you something out. Take a look at the word stream. Stream is something that in more technical languages, it gives you a better understanding of what a stream is. But a string, or input, I should say, is a stream of characters, right? And so, especially in Java, when we do this, when main is expecting a string of an array of strings. That's correct. Let's see, I want to just be focused on the questions themselves, as there was an abstraction describing something having no limits. Okay, so let's go look for that, because I do talk about these things. Here it is.
Miss Alia,
Yes.
Sorry, could you just go over one more time? So an input-output abstraction is just an abstraction that takes an input or produces an output?
Yes, that's correct. Let's see. Does it say something like that? Yeah, but what you just said is actually pretty much an abstraction of providing um, uh, input and output of, from a program to a program. Something in those lines will be sufficient for a good answer to that question. Then here's another very, theoretical question or concept. Infinity is an abstraction describing something having no limit. I mean, what is infinity? I mean, the word infinity alone itself is an abstraction, right? Because can you really physically touch it, see it? No. So technically, it's something that we create. It's an idea. It's an abstraction. So here's a infinite output sequence. I think there's a question like that over here. It says, what is an abstraction for an infinite output sequence? So standard output stream, like what? Give me an example of standard output stream. And somebody that who hasn't said a word yet. I hear always the same people giving me answers. Like, I don't know. Marwin, are you there?
He messaged me that he was going to the bathroom.
Okay. All right. So what about Ryan? Ryan, what would be an example of an output stream in programming? And I can see it on the page, on the slide itself. So it's not a tricky question. Ryan, are you there?
Yeah, I
Yeah.
am. I was having a bit of trouble hearing you.
Okay. So do you know the answer? What
I'm
would be
sorry, what was
the question is, what would be
sorry.
an example of an output stream where it says an abstraction for an infinite output sequence? And I can see it on the slide on the screen.
Yeah, it would be print like the example that they give is printing an infinite number of random
Yeah.
of random numbers or a finite number of random numbers, but you could also do like anything that's like, you print out all the integers in order 1, 2, 3, 4, 5, 6, 7, 8, or
Right.
just any like letters of the alphabet.
Mm-hmm. That's correct. So system out print line will be an abstraction for an output stream, right? You use that for output, right? STD out from the university libraries, that would also be another abstraction for infinite output sequence. What's the next question? Somebody give me, what's the next question?
What are the
components? Oh, sorry, you can go.
Come on.
sorry.
That's
What
okay.
are the components of the improved input-output abstraction?
Okay. Components? Does it say the word components? Yeah, of the improved. Oh, okay. All right, so very good. Here's the improved input-output abstraction. So we looked at the one before. Remember the picture before, in which we have, it was very simple. Image over here, there it is. You have the command line arguments, you have the standard output stream, but then we have an improved version of it. Why does it make it improved? I want you to look at that picture. It's on page 10. What's different?
Yeah, I know it also takes the command line argument. I think it's args0 and something and standard input stream. I think they were all taken into account and produce an output.
That is correct. So Jonathan, was in Ian is 100% correct. So Jonathan, I'm asking you, what is different in this slide from the one that I showed you before?
There's a standard input stream.
That is correct. Yes. So you have the standard input stream and the standard output stream. Now, this is improved because what happens is that the university created another layer of abstraction. Did I submit this? I didn't. Oh, yeah, I did. Created another layer of abstraction. All the standard libraries are actually written in Java. And so you don't have to actually go to the native language Java. You use this std draw, std out, std in. And if you look at it, it's again, you're actually calling a whole bunch of programs that were already written in Java. So it's another layer. And it's another layer of abstraction too, because we don't have to worry about the details. Keep that in mind. An abstraction eliminates details, minimize details more than eliminates. So what's the next question? Guys, ask me the question because don't you want me to give you the answer? Otherwise,
It's what is an abstraction for an infinite input sequence?
very, very good. So here we have an abstraction for an infinite sequence is the standard input stream. Simple as that. It might sound trivial to you, but it's not. It's not at all. And it's important the word standard be there. There's so much going on behind all of this that it will be like overwhelming to actually take a look at what's under the hood of this standard input stream. And the good thing is that it's an infinite input sequence. Like, remember when we did the random sequence and we found the average and we just put any numbers in there? Of course, computers can never be infinite, right? But we technically, we can get to big numbers, something that it will go on for a very long time. And we will not overflow, we don't run an overflow because we don't store the information. We process the information and we don't hold on to it, we don't store it. So that's the answer to the question. What's the next question? Somebody else, somebody who hasn't talked. Gran, what's the next question? Somebody wants to
Sorry,
help
I'm
Gran?
lost.
Somebody wants to help Gran because Gran is in the twilight zone.
It's the same thing except like what's an abstraction for an infinite output sequence.
Thank you. Very good.
Thanks.
Okay, so if we go
I'm still a
down.
little confused.
So do you know where we are? Do you know this? Do you know we're doing this?
I've lost my way.
You've lost your way.
Yeah.
Well, get back in here. So if you're in the modules, right, go to module 6, 6.6, which should be the last post. Open it up and click on the website. If you click on the website, the questions are there too, and you want to answer them as we talk because I want you to turn it in as by the time I finish talking, you should have all the answers.
Mhm.
So if you lost your way, you better get back on the horse.
Yes.
There we go. So the question was again the same thing, which was an abstraction for an infinite output sequence. And so, well, we have the standard std out. Here we go. We have a system out print line. So we have a whole bunch of things in which actually we at least know 2 of them. There are more, definitely, but those are the ones that we can work with at this point. Because output can be also with sound, right? With images, not necessarily just the std out, which is a sequence. I'm not sure even need output sequence, right? Well, right. If we're looking at an output sequence, yes, we're thinking about std out and system out print line. These are the same as system out. Why not use just the system out print line? I don't know why.
Because we want it to be consistent.
Very good. Consistency is one of them.
It's shorter and easier to read.
It's shorter, that's for sure. I don't know who came up with this system of print line. After so many abstractions that they come up with, couldn't they come up one more just to make that a little bit, shorter? If you use Eclipse, I think it's a sysout. If you type sysout, it represents system out print line. So here is what Julia was saying, consistency. We can change the implementation to intercept your output, facilitate grading. Oh, right. Okay. The university tried to find a lot of ways to have very uniform and consistent work. So it's easy to manage, especially for grading purposes, because the numbers are quite big. What's the next question? Julius. There are two Julius. Let's see who answers. Who has the next question first?
It's number 8, which is asking why not like just use System.out.
Oh, okay. So I think, is that the same question twice? Did I ask the question twice? Yeah, that's what we just answered. We answered that.
Yeah. Oh, okay, yeah.
Here's the answer. Take a look. It's right here. We can provide consistency, and then we can teach. I mean, the consistency idea is probably stay best, and saying that it's shorter actually makes it easier. What about the other Julius tells me? What's the next question? Julius Varm. Who just answered before Bosch?
It's me, Julius Verma.
Varma. So the other one is starts with the where is Bauk? Bauki? How do you pronounce your last name, Julius? Are you there?
Buka.
Buka. Oh wow. Buka. I like that. So what's the next question, Julius?
I don't know.
Why not? You don't know where we are?
No.
Oh my God. So why don't you say something, even in the chat?
I bet.
Okay, so go to modules. If I'm moving too fast, I mean, chat, you guys can tell me. Go to modules, go to module 6, last post, click on that, and then click on website. Now you should be answering these questions, which are the same ones, and it would be good if you copy and paste these onto the actual text tab, so we can you can answer them, and I know which question you're answering. So if you're missing the previous ones, just move on to number 9, which is interactive input. Prompt the user to type inputs on a standard input stream, mix inputs and streams. Okay, so what is that referring to? Let's take a look over here. Here's the interactive input. That's page 14. Yes. So this is something, once again, this is something that we have done. We're just we're having these very conceptual discussions because it is important that we do this. So we have the standard out, the standard in. Take a look at the two of them. They're interactive. So we are looking at, you can copy actually this code to it, just like this. To that number 10, right? That was 10? 9, sorry.
So we should just like put that code in?
Yeah, I would do that. Yep.
Okay.
Yeah, you can do that. That would be a perfect way to make a statement about that, because I don't think there is even a question right? These are all things that I expect you to, you know it, but I expect you to be able to recognize it when I talk about it.
But I think like the scan dot next in the next double, does that also count as input stream?
That is correct. Very good, Ian. Yes, it is. Scanner will be for input, right? And so instead of having standard in, you can have a scanner. Ian, if you're interested, if you go to the standard in that Java class, you'll see that what they use is a scanner. Because again, this is another layer that they created to make things consistent and more simple. So they use a scanner. Okay, let's see. Jessica? Wait, what was, yeah, I forgot. Oh, don't go. Don't go. Oh, stop that. Oh, no. Jessica. Yes, I thought it was Jessica, but I wanted to make sure. Jessica, what's the next question or the next thing that we have to look at?
So number 10, average.
Average. Okay, let's scroll down. And here's the average. Which we already have done this, if you remember. So take a look at and pay attention, because when we did this, we were doing the average of the random sequence of numbers, remember? And so then we have to know how to get out of it, because the standard in is empty, has only takes these control keys. So you can put this in your, you can copy this like this in your text tab. And again, we have no limit on the size of the input stream. Remember the way we did this, we never said to store it or anything. It just went through the stream. We read it, we processed that information. We kept on adding it. If you look over here, we adding it, but we don't store it. All we store is the sum. So the only overflow you have over here, it would be because some maybe it becomes too big, not because we run out of space to store information. It's just that that variable can only hold, a specific amount of digits. Okay, what's next? Shoshi? Is that Shoshi? I think that's Shoshi.
Yeah.
Yes.
Yeah, I
got
can't
it right.
change my name from Shoshana for some reason. What number?
Oh, sorry. What's the next one?
I think it's how do you specify the end of the stream?
That's right. So I think everybody knows by now, right? It's Control D. I'm standard for the kids, meaning that's coming from I think it's the Unix system, and then Control Z if you are running in a PC and a Windows machine.
But I think to control the end, I think we can just like hot the program.
With the last part, what was it? What we can do to the program?
So like if the program like has an infinite standard output,
yeah,
we can just click on the red arrow to force quit.
Yeah, except that if we do that, then we won't be able to see the average, right?
Yeah.
We don't want it to force quit it, because then we crash the system and we cannot see what the average was at the end. So this one we by using one of those control keys over here, then what we do is we stop this while loop, the input, and then it goes on to the next line, which is the standard printout, the std out print line, and that will give us the average. That's the difference between the two of them. So here they use the Control D, And so we get that information.
Miss Celia,
Yes.
for for number 9 and number 10, we don't have to put like an answer, right?
No, there are no answers. Just copy and paste the programs. For 10, is this one? Copy this.
Okay.
You can copy this like that. And you don't need to put the main, just that's code snippet. And for 9, you copy this. Again, just the snippet, the code snippet. We don't need main.
Okay.
And just remember that when we, and not just you, for everybody, we're doing this. So when I talk about it, you know what I'm referring to. The same thing when we say, how do I specify the end of a stream? You should know that in our case, most likely, or not, that's not true completely, but most likely it will be Control D. But if you're running in Windows, it will be Control C. So that will be the answer that I expect you to put in your head if we're talking about how do you specify the end of the stream. In this case, we're looking at the input stream without crashing or forcing the program to end. We just want to end this infinite loop over here that will continue to go for as long as we don't press a control key to terminate it. Eugene, what's next?
How do I specify the end of the stream?
Very good.
I think we use Control D or force quit.
Not force quit. Remember what we said. If you force quit, you crash the program and you won't be able to see it at all.
But if the computer is running infinitely, this can make
no, that's different. Okay. Yes. Ian, you're right. If your program goes into an infinite loop, I mean, that's an error, right? Yes, you have to force quit it.
Yeah.
But if we are in a while loop like this one, take a look at this one, Ian. We are taking input. We're in a while loop that doesn't know how to stop asking for input.
Yeah.
So the only way that we can terminate that while loop of input is by using the Control D or the Control C. So if you do that, then it will stop the while asking for input and it will go to the next line, which is actually calculating and displaying the average. And you understand the difference between the two of them? An infinite stream is that we didn't say how much information we're going to get. We're not saying, well, for a for loop of 100 items. Here we don't have that. We don't have that at all. We don't know when this is going to end. So the only way we can end it is with one of those control keys. So it looks like it's the same answer. That would be that question, right? I don't think there's another. Do I always have to type in? Blah, 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 blah. Yeah. What's the next question? Ethan. Ethan, are you there?
What is the limit on the size of the input stream?
Very good. Okay, so take a look at the answers right here on page 16. There is no limit on their size because this is the way they were designed, both of them. The limit is when you use it as an argument. Do you all remember how we did that? Let me refresh your memories a little bit over here. Oops, I didn't mean to do that. Hold on. I think it was in 2, right? Yes. So if you remember this, So let me shrink this a little bit. When we ran the average, right? We said Java, and then we did, let's see. Sequence. And then if you look at random sequence, right? We need, it doesn't have a finite or predetermined, I should say, number of repetitions. So we have to actually give it to it as input, an argument. And in this case, we can say 100. There we go, right? And then if we did the average, do you guys remember how to do the piping? Who remembers that? I'm thinking myself. And then it was the particle line. And then we did Java average. There it is. So average certainly will take for as many numbers as you feed it. It's not predetermined. So maybe infinite is not the best word to use because obviously there is limitations, right? With the hardware you have and how the size of the variables are, even though we're using double, it will have a limit, but it's not predetermined. So, so we predetermine, it's not predetermined here, it's not predetermined there. So they make it look like, okay, there is no limitations to the size, which is true. You can change this. And I think at one point we tried a big number. Remember when we did this once? It was a huge number. It takes a little bit longer, but it obviously, it looks almost like it's infinite. You can go on forever. And there it is. Look how close it is to 0.5. Okay, so what's the next? Let's see, Brendan, what's the next question? Oh, there's the piping to remember. Yeah.
Is it the last one? How many spaces are printed before digit 3? Or
Oh, yes, let's do that one. So let me bring that up.
Miss Alia,
yeah.
my brother's here to say hi.
Hello.
Oh my God, how you doing?
I'm good. Sorry, I would love to catch up, but I'm late to my flight as I always will.
Yeah, yeah, that's terrific. It's so good to see you. Good luck. I'm glad that you stopped by. Bye.
Yeah.
A big kiss. Bye.
I'll be back in a second, Miss Alia.
Okay, bye. Okay, let's go back to, I think you, Brendan, you skipped something if I'm not mistaken. Did I answer all the previous questions besides that?
I might have went ahead, but
yeah. With enter limit, do I always have to type in my input data and print my output? No, that was, so the answer to 13 is piping, right? You saw what I did. Right. So the answer is piping, and we did that somewhere. It should be on that PDF if I'm mistaken. Let me go back to the PDF. There it is. There we go. So you want to copy one of these two and use the word, use piping. And then what can you do in the room for a huge file on my computer? Again, we don't have to store it. We just process that information. Do they say anything else over here?
Wait, Miss Adia?
Yes.
So when it says if you don't have space for it on your computer, wouldn't that be strange? Because if you didn't have space for the file on your hard drive, instead you were piping it where it stays in RAM, which is usually smaller than the hard drive. Wouldn't there be something weird with that if you had more RAM space?
Well, no, but remember, if we let's go back over here. Over here. In RAM, right? All it's doing is kind of the information is kind of passing. It's not staying. It's taking one number at a time. And
So does it not complete the first program before it sends that data
no,
to the
it's
second
not.
program?
That's
so they're running
correct.
at the same time.
Right. Yes.
Oh, okay.
Well, no, that's yeah, that's correct. Yes, that is correct. Because it has to do that because it has this one is going to be adding to it, right? So this one is generating the random number. It will not complete it and then do the average. Otherwise, yes, then you run the problem into there's not enough space. So this is printing. When it's printing, it's actually being redirected to the average. Remember how we did that in 2 steps? Piping, we did it in 1 step. So
okay, thank you. That makes sense. Yeah.
Okay, very good, excellent. So that's a very, very limited usage. But obviously, if you're processing lots of information, that is definitely a good way to get out of the problem of running out of space. And I think we're almost done, right? The last one is here. How many spaces are printed before the digit 3 in the following statement? Anybody has an answer?
8.
No, 8 is the whole thing. 8, when you start with 8, you tell the size of the actual field. This is how much space you're going to have to put your data, your output. Where's my notes here? And I think somewhere in there, there is that right here. Take a look. Here's is telling you how it works. This is the field of it. The field width. So if I copy this over here, and you should be copying this onto your text file there. So then the width, I think that's how you spell it, of the whole output is 8 spaces long. So you have to fit, so if you have 1, 2, 3, 4, 5, 6, 7, 8, right? So, and then you have 3 decimals. Wait, what was the question again? How many spaces are printed before the digit 3? So, so there are only 3 decimals if you think of it. So I think it would be 3 point, oh no, I need more space. It would be 3.141. There it is, right?
So what does the 8 stands for?
It's the whole field, the whole. So you dedicated this much space in your output to print a number. So in this case, you're going to be printing the pi, the irrational number pi, but only 3 decimals, up to 3 decimals. Here's the 3 decimals. Then you also have to count the decimal period, and then the 3 in front of it. So the question was, how many spaces are printed before the digit 3? So how many spaces?
3.
3 spaces right here. 1, 2, and 3. This is 3 blank spaces. And I think we're finished, right? 3 blank spaces. You should copy this exactly the way I have it over here. Well, not necessarily this line, but certainly you should have this 1 through 8 and a line, right, justified the 3.141, which is only 3 decimal places after the decimal periods of their irrational pi, because I think it's 31459. That's all I remember. What? Correct me if I'm wrong. No, nothing. All right, think we're done.
Yeah, I have a last question.
Yes, go for it.
What does piping mean?
Oh, piping, we did it over here. Piping is when we take information from process information from one program, the random sequence, and is being passed to another program. So we started here, we ran random sequence, and as it was processing, as it was creating the random, there we go, here. As it was creating the random numbers right here, it was giving that number to the average, and the average was adding it to the variable sum right here. You see this variable sum? So this program gives to this program what is generating, and this one is processing that information as it's coming. The only way you can do that is with piping. And here's the actual syntax right here, but it's also in here, right? So you can copy directly from here. I will copy, probably this one is the one, the best to copy. Ian, did I answer your question?
Yes. So piping, I think, is just connection between any random 2 or 3 programs.
Yeah. Yes, that is correct. Where's the rational number pi? Just want to know if there was. Just give me the number. Oh my
it's
god.
3.14159.
Oh, there. Okay.
358,979.
Oh, right. I will never remember that. All right. So we are good. We have everything. Did I answer all the questions?
Yeah.
Yes. Everybody's good. So I recorded this. I'm going to put it back. I'm going to put it in a link right here. So if you missed something, if you were one of those that I'm totally lost, then you can do it. But I want it to be done today. Tomorrow, next time we meet, we're moving on. And I would like to, I know seniors need me to have finished grading all the stuff, but it will be finished, okay? So it will go in the transcript for the mid-year grade. I'm gonna stop recording if I know how to do that from here. How do I stop recording? Oh, there we go.